So in the last few sessions, we talked about Spark SQL and data frame, and we also talked about the dataset API, and few of the examples were also on the Spark 2.0 using the sessions. So it is always recommended to use the sessions as Spark 2.0 will be going forward, and that should be used. And if you go through the 2. Spark 2 experiments project, most of the uh, uh, examples are in 2.0. So you can go through those examples. But we know that what is a data set now? What is a data set now? So so till now we have learnt about the batch processing. Spark Core was all about understanding the concept. Then we moved on to Spark Data Frame, where the actual processing should be done using the data frame APIs or the dataset API. RDD APIs will remain as an internal API. So next we will move on to the Spark Streaming. So before we move on to Spark Streaming, we will talk about Kafka. The idea is this. So in Spark Streaming, I'll just give a brief the connectivity between the Spark Streaming. What is Spark Streaming? We'll not see any example as of now. Later we will see the examples. So when I say Spark Streaming, it is all about you are continuously getting the data from somewhere, and you process the data immediately and give the result back immediately. That's what we mean by Spark Streaming. Just like Spark SQL is a library on top of our Spark framework, Spark Streaming is also a library on top of our Spark framework. So here you have your Spark Streaming library. So this library we can connect directly to a network application. Some application which is running on some IP address and port. But usually it is not recommended to do this. There are many reasons for this. We will discuss those things later. So usually what happens, the application sits somewhere. I will say application 1, application 2, and so on. In between you will have some buffering framework. So Kafka can be used as a message queue here. The application will send events or messages to this message queue. Kafka is a message queue, and that message queue will be consumed by our Spark streaming library. Similarly, instead of Kafka, you can have Kinesis. Kinesis is also similar to Kafka, but a managed service from AWS. So that also works fine. Or the applications can send the data to 0MQ or many other, or RabbitMQ. Your applications will be sending the data to these message queues, or you can get your data from RDBMS and push it to Kafka as events. Any new update happens to the RDBMS, those updates will go to Kafka as events, and again it can be consumed by your Spark streaming application. And once it consumes, Spark streaming is all about consuming the data. Then internally it will use the Spark core to process the data. So that's how the relationship between Spark streaming. One second, I think there is a I hope I am audible. Okay, there is a power loss here, so I have switched the network. So this is where Spark streaming plays a role. So all these things you can think of a message queue. These are all your message queues. So Spark streaming always so to generalize this, you have applications. These applications can be sending the data to the message queues, and Spark streaming will consume the data from this message queue. That's the simple way to look into the Spark streaming. So it's just one more application which continuously consumes the messages that are coming or events that are coming, and then it will process it and store it, or store it somewhere, or send it back to Kafka. Anything can be done. So you can store it to, to, to some NoSQL database like Cassandra, or you can save it back to Kafka, and from here you can send it to RDBMS. Anything could happen. It all depends on your uh, project architecture. So let's understand. uh, Keeping this in mind, I will stop the Spark streaming right here, because will Spark streaming can connect to network applications. Spark streaming can work with Kinesis, Kafka. So we'll talk more about Kafka, because that is a standard integration of Spark streaming and Kafka. Most of the companies prefer Kafka and Spark streaming. So let's understand what is a Kafka here. So as I said earlier, Kafka is a message queue. But to generalize that, Kafka is a distributed, actually. Distributed. It is persistent. It is circular message queue, or we will say central repository. Kafka is a distributed persistent circular message queue or central repository. So now what do we mean by distributed? So why Kafka came into picture? Why Kafka? Simple question, but usually the answer will be a bit tough for some simple questions. So let's see why Kafka is required. Now earlier systems, what traditional systems, if you take, the traditional systems will have a message queue. It could be a Java message queue or anything. Some language you have used to implement the message queue. So obviously processes will be sending messages to that. Process 1, process 2, process 3, and so on. Process N will be sending messages here. So this is our message queue. Now this message queue could be memory based message queue, or it could be file based message queue. So if it is a memory, If the system goes down, the data will be lost. If it is a file-based message queue, even if the system goes down, nothing happens. Your data will be available on the system. And there will be some consumer process which will be consuming the messages process, something like this, and so on. But if you see here, this message queue is usually implemented in a single system. Hence it will be limited by the resources available on that system. It will be limited by the CPU core, RAM, and disk size of that system. If you connect this to a Spark application, if a Spark application consumes from a message queue, so your bottleneck will be the message queue, because Spark can process lot of millions of data, but you may not be able to send millions of records to the message queue because your message queue is limited by the resources, since it will be running on a single system. So since our processing application is a distributed application, it would have been better to have a distributed message queue, to have a distributed message queue. So that's where Kafka came into picture. So instead of having a single system based message queue, we'll have multiple system based message queue, and hence we call it as a distributed message queue. Now what is persistent here? Again, when I say persistent, data will be stored on the disk. So whenever a process sends a message, the data will be stored on the disk, and the consumer will consume those messages. So that's what we mean by persistent. It is a disk-based message queue. Now, what do I mean by circular? Circular means you keep on sending the messages. As the messages get old, but by default, let's say it is 1 week. As a message becomes 1 week old, those messages will be removed from the disk so that space is made available for the new messages. So that it looks like a circular message queue. Older messages are deleted, and room is made for the new messages. New messages are accumulated. So that's the reason we call it as a circular. And since will be multiple processes, applications, now applications will be sending the messages to this message queue. Or we sometimes also call it as a central repository. I mean, this is the one reason this is one reason why why Kafka was introduced, because of limitation of RAM, disk, as well as CPU core. It may not be clear that why CPU core comes into picture, but CPU core is also more important when we implement a message queue. You may only think that, obviously from this, if you can see, RAM and disk seems to be more important, but core is also important. We will see those as things as well. So that's the number one, one of the reasons why distributed message queue is required. Second reason is so it acts as a central repository. Now what do I mean by central repository? Central repository is nothing but, so Earlier, what used to happen, there was some application 1. Application 1 data was required for some analytics application, application A, I will say. So this is an analytics application. It used to analyze some data, and from this application, and give some statistical analytics on top of that. Then some one more app got application that company developed. Let's say application 2. Now this application 2 data was required for application A for doing some more analytics. Obviously, they have to develop an interface in application A and an interface in application 2 so that they can send the data to each other. And not usually on one side. Application 2 should be sending the data to application A. Later on, they developed one more analytics application, application B. And it also required the data from application 1. So again, some interface has to be developed on application 1 so that it can send it to application B. Now since they are modifying application 1, now they have to test that application 1 again for whether the data is being sent to application A. Something might have broken. Something might have broken, so they have to test it because they are modifying this code once again. So on, there could be multiple analytics application. There could be multiple analytics application, and there could be multiple user-facing application or some other backend applications from where the data may be required, and so on. And this data may be required here, this data may be required here, this data may be required here, this data may be required here for doing all kinds of different kinds of analytics. Now as you can see here, such kind of a things is hard to maintain. If your architecture is in this fashion, if your architecture is in this fashion, it will be very hard to maintain the piece lines of code, because you have to start writing interfaces for every application, for every analytics application to whichever. So this as you can see, if all this analytics application requires data from application 1, obviously you have to modify the code, add interfaces in this application 1 so that it can connect to all the analytics application. Now any new application you introduce now, any new application you introduce, or any new analytics application you introduced here, so you have to add an interface here again. Once you add an interface, you have to test it for all the other interfaces because something could have been broken. uh, do you hear a lot of disturbance here? Is there a lot of disturbance? Because it is raining heavily here. Okay, okay. Yeah, as I was saying. Okay, so as I was saying, uh, so so every time you add a new analytics applications, and add its interface to our your normal applications, the whole system has to be tested every time. Whole system has to be tested every time. Hard to maintain code base. Hard to add new modules, new applications. Every time you try to add, you need to test the whole system. So these are all the drawbacks, or this is what also led to the development of Kafka, where Kafka will act as a central repository for different kinds of applications. So all these applications will be sending the data to Kafka. So they don't have to change the code at all. And you will have the analytics applications consuming from from Kafka. Application A, application B, application C, application D. So here application one may be one may be some your click data. Here it could be some ad impressions, or it could be sensor data, your search data. Anytime you do a search, an event will be sent to the Kafka. Anything good could be. So here your application A could be application A could be your Spark streaming. Here it could be Flink streaming. It could be Samza here. It could be Storm. It could be Kafka streams. It could be Flume. So as you can see here, this is a more refined architecture. This is a more refined architecture. Kafka streams. It is Kafka streams. It is similar to your Spark streaming. It will consume and start processing the data. That's Kafka streams. So, I hope I will explain a bit few more details on Kafka streams. I will give a bit more details. But it is nothing but it is a processing capability. Now, as you can see here, this is a more refined architecture and a good architecture, because you need not test every application wherever you add a new applications. They are all sending it to Kafka, and everybody is consuming from Kafka. So that's your a distributed message queue, or or usually we can in this context we can represent we can we can have a perspective of saying it as a central repository. It is acting as a central repository for all your analytics application. Anything happens in your company, from different apps you are getting the data. It could be from RDBMS also. You may have some web applications here. From there, your RDBMS, you are saving or updating some data. That also could go to Kafka, and from there it can be consumed and can be processed. So that's Kafka for you. It is a central repository, or you can think it as a message queue. And it is an independent framework. It is not part of Hadoop. Not part of Hadoop. It is independent framework. It is an independent framework. So I hope you got the idea of Kafka here. Now keeping this in mind, earlier this Kafka was developed by LinkedIn. It was developed by LinkedIn. Now the LinkedIn backbone is Kafka. Anything you do on LinkedIn, it will go as an event to the Kafka. Anything that you do on the LinkedIn website, everything goes to the Kafka. Their company is standing on the Kafka there. Kafka as the backbone is being used in LinkedIn. Now later what happened? Later they started a company called Confluent. The creators of Kafka, the creators of Kafka, they started a company called Confluent. Now Kafka is maintained by Confluent. So it started as a message queue. It started as a message queue. Now this company, they want Kafka to act as a platform. Kafka to act as a platform, not just as a message queue. So if we use Kafka, Confluent Kafka, you will get normal Kafka. You will get this. This is a Kafka message queue. You will get Kafka Connect. You will get Kafka, Kafka Streams. You will get Kafka REST Proxy. Recently, they have introduced KSQL, Kafka SQL, so that you can process your data using, just like in Spark we use a data frame on which you can give SQL kind of queries on your data frame. So you can give the SQL kind of queries on the data stored in the Kafka. So that's the idea of KSQL. So these two are, I mean, linked together. So using Kafka streams internally, we use the KSQL. So here as this is a I will be talking mainly about the Kafka, because this is a central to all these things. Kafka message queue is central to all the other components of Kafka. Everybody uses the Kafka message queue. All the other components uses the. So as you can see here, they just want to make Kafka also as a platform, not just a message queue. They want to make it as a platform. so that an end-to-end applications can be implemented with most of the Kafka component and have minimal dependency on other components, or have minimal dependency on other frameworks, so that most of the problems can be solved by only one framework. That's the idea. I will just give a brief of how all these get connected. Now we know that Kafka is a message queue. Kafka is a message queue. Let's say you have some web application. Now through the web application, you can use the Kafka REST proxy. From this, you can send the messages to. So this is your Kafka. When I say Kafka, I mean Kafka message queue. So from your web application using REST proxy server, you can send the data to your Kafka. Once the data is there in Kafka, you can have Kafka streams. It can consume the data. It can consume the data and do some processing out of that. It can do some processing. After processing, it can save the data back to. It can save the data back to the. I mean to say Kafka. So let's say this is all about reviews. Any user gives a review on some product. Some product they are giving their reviews. Those reviews are sent here. Each review is sent as a message to the Kafka. Anything they send it. So Kafka streams will use that. Internally again it will. I'm just trying to give where all the components fit. So once the data comes into the streaming, so it can have some machine learning model here. This could be some different framework, not part of Kafka, because Kafka does not support ML. So here it could be a Spark based or any other simple machine learning model. So it can check whether it is fraud or not fraud, whether this review is a fake review or a real review, and save those things separately. So that's how it can be stored. It can be stored in this fashion. Once it is stored, you have to show this on the web UI. On the web UI, you have to show these things. Which one is a fake review? Which one is a good review? So from Kafka, how can you send it to? So this web application may be powered by some MySQL database. This web UI may be powered by MySQL database. Now, how do you send the data from Kafka to? MySQL database. So that's where your Kafka Connect comes into picture. So as you can see here, this is what they want to achieve, Kafka as a platform. So Kafka streaming is all about having the processing capacity. This the core of your Kafka platform is Kafka message queue. Kafka Connect is all about data transfer from one storage to another storage. So that's the idea here. Anywhere you want to transfer the data as events, so you use Kafka Connect. So just to give a more idea on that, let's say you have all your data in MySQL. So any writes or update happen, so those will be sent as events. So this is your Kafka Connect. So Kafka connects, takes care of that and sends it to Kafka. So this is called as source connect, and from here you want to save it to HDFS. So you will have a again Kafka connect, which will call it as sync Kafka connect, and it will save the data to HDFS. So if you want to save it to Cassandra, so there will be a Cassandra sync. This is HDFS sync. You can have Cassandra sync Kafka connect. So from one external storage, you want to store the data to some other external storage. Kafka Connect helps in that. It does not have any processing capacity. Kafka Connect is only used to transfer the data from one external storage to another external storage as an event. Each operation that happens on the external storage, that will be treated as an event, and it will be sent to Kafka. I think it resembles like Oracle Golden Gate. So if you want to send messages, events from the Oracle to some message queues, you will use the Oracle Golden Gate, or I think other open source Golden Gates are also available. So you can think of Kafka Connect similar to that, but has lot of connectors. There are many connectors available. You want to store it to Amazon S3, Amazon S3 connectors are available. Source connector and sync connector. HDFS, we have Cassandra. Most of the NoSQL databases and all the RDBMS databases, all the connectors are available. Elasticsearch you want to store, you can store. Anywhere you want to store the data from one system to another system, Kafka Connect can be used. So I hope how uh, I mean how they are trying to make Kafka from just a message queue to a platform. How they are trying to do it. So here I hope it was the overall architecture was clear here. Instead of this, instead of these two, instead of these two, you sometimes the most preferred thing is instead of using this, the most preferred thing here is we can use Spark streaming. You will have ML Spark ML model. It will predict whether it is fake or not fake, and it will send it to Kafka. And in between again you can have Kafka Connect, and it can send it to the MySQL. Anywhere it can send it so that it can be viewed on a web UI. So because you want to review, check whether it is check whether the review is a fraud or not fraud. It may not be immediate. It could be here 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 the best use case of Spark streaming will be your credit card swipes, because that's where the streaming will be more useful. This is fraud. So that you cannot give the check whether it is a fraud after 1 day. The reviews can wait. You can say that this review is a fraud review or a fake review after a day. But credit card swipes, it has to be immediately said that it is a fraud transaction. Somebody else has uh, done a transaction on behalf of you. So it will be sent to the Kafka as fast as possible. Spark streaming will immediately check and send it to the Spark model. Spark model will immediately predict whether it is a good or a fraud, and it can send it to Kafka again. From there, it can go to MySQL, or from here itself, it can be sent directly to some MySQL also, or it could be sent to Cassandra as well. Any applications it could be sent. I mean to say, the better use case would be not in this fashion. From here, the good will be lot of transaction will be there. You may not send it to MySQL. MySQL may not be able to handle a lot of good records. Fraud may be very few records. So you just send it to MySQL. Your good records are your kind of a raw data. So you can send it to Cassandra here, because there will be lot of good records, good transactions. And from here you send all the raw transactions to raw data. You can save it here. Good records again can be saved as a separate table. Table 1, table 2. Table 1 will contain like good views. Table 2 can be our raw data. whatever is coming from our Kafka. So I hope you got a overall idea of where all these things can fit in, where all the things can fit in. I mean, there are some more things. I'll just put one more high-level diagram. So your some application. So it could be web app, point of sale, lot of places you can swipe. So from everywhere, you will be sending the data to Kafka. So you will have some collector app. From that collector app, you will be using some Kafka REST proxy, send it to Kafka. So your credit cards are being swiped many places. So once it comes here, you can use Spark streaming. Then internally use the Spark ML, fraud, not fraud, predict and send it to Kafka we said. Now this machine learning model will be picked from some one more Spark application. Spark app. It will read the data from raw data is coming here. The Spark streaming will be sending this here. This is your raw data. Good data can also be stored here. Your raw data will be read by your one more Spark application. This is one Spark app one Spark application. This is second Spark application. And on the raw data, it will do the training part. After doing the training, it will send that model to this. I mean, Spark streaming application will pick that model. It will pick that model and it will keep on predicting what is a fraud or not fraud. So this Spark ML job, it could be running once a day, once a day, or once a week, something. It could be. It's all depends on you. How much data, how many transactions you are getting per day. If you are getting some millions of transactions per day, obviously you have to refresh your machine learning model. You cannot use the old model to predict the new data, because you are getting raw data again and again. So what you will do is you will rerun this. You take again the raw data, which includes also the new data that has arrived. Again you prepare your machine learning model, and Spark streaming application will have to pick that new model every once in a day or once in a week, based on how much data you are getting from your things. And this can be going to the MySQL, Oracle, anything. And here you will have a web UI which will showcase whether it is a fraud or not. So this is exposed to some internal team, internal team who are experts in detecting fraud. They have the domain knowledge. They have the domain knowledge, so they can check, because this could be fraud or not fraud. It is only a prediction. It's only a prediction. It could be fraud or not fraud. So they will go through that transaction, and they can call you. They can call the customer and check whether it was a good transaction, or a fraud transactions. All those stuffs they can do. As soon as they get an alert, they can check, cross check once again whether it is really fraud or not. They can also call the person and check whether they have really done any swipe or not. So that's how the end-to-end pipeline looks like, if at all you want to develop a credit card based fraud analytics. Yeah, here is a question. The question is what is REST proxy? I mean, if at all you want to send the data through HTTP, you don't want to send the data through the normal communication protocol. You use the HTTP protocol to send the data. So Kafka also supports sending the data through HTTP. So that's where the REST proxy comes into picture. I mean, it makes your sending of data language independent. It makes your sending of data language independent. But I hope you got the overall idea of where all, which all framework fit in, which all framework fit in. And also one more thing to remember is, if you want to transfer the data from one external storage to another external storage, I said that we can always use Kafka Connect. We can always use Kafka Connect. Any data transfer from one external storage to another external storage. And in between, if you are using some processing using Kafka streams, so let's say you have source Kafka Connect, Kafka, and you are getting the data from MySQL, and you want to save it into Cassandra. Here is a question: is Kafka Connect a single thread or multi-thread? So that's a good question actually. So that's what the problem they wanted to solve. So actually, it is a earlier the way the data was being sent to Kafka was a single threaded. Now Kafka Connect is a multi-threaded. It's a distributed way of sending the data to Kafka. It is distributed way. So that sending of data is also fault tolerant. Not just Kafka message queue itself is fault tolerant. Now sending of messages will also be fault tolerant. If some of the system go down, you should still be able to send the data to Kafka. So that's what the Kafka Connect is all about. They want to make the sending of data and from one system to another system a distributed and fault tolerant. I hope Rohit that was clear. Now as I said, MySQL, you have your source connector and you have sending the data to Kafka. Now and from there you want to transfer it to Cassandra. Now in between you want to do some transformation using Kafka streams. You're doing some transformations using the Kafka streams. Now this after doing this transformation, it is not usually stored here. This is not done. You don't directly connect to the external storage from the Kafka stream. So from the Kafka stream, you send the data to Kafka message queue again. From this message queue, you will use Kafka connect again. You use a sync Kafka, Cassandra sync. So this is how the whenever you use everything in terms of Kafka, it should be in this fashion. So I hope you got the idea here. The main thing is how the end-to-end pipeline looks like. So let's most of the things I will be covering is on Kafka. The things that I will be covering here is on Kafka, and I will be covering Spark streaming. We may not have the Kafka Connect and all. I won't be covering Spark, Kafka streams, Kafka Connect. Those things I may not be covering, but I hope you got a idea where all these things fit. Where all these things fit. Similarly, we'll be talking about Cassandra. I am actually developing an application based on this itself, an end-to-end pipeline project I am creating with credit card swipe, whether to whether the credit card is a fraud transaction or a good transaction. So it may take some time. So then I will prepare a video out of that, and it will be uploaded to showcase how this end-to-end machine learning, Spark streaming, Kafka Connect, MySQL, some Cassandra database, how all these fit in one end-to-end pipeline. Now let's understand the Kafka message queue here. So when we say Kafka, there are multiple components or concepts that we have to learn in Kafka. The concepts here are topic is one concept, partition, replication, producer, consumer, broker. Then we have leader copy, or sometimes it is also referred as leader broker, follower copy, or sometimes it is also referred as follower broker. Then what we have is follower copy, follower broker. Then replication we have, partition we have producer, we have consumer, we have something called as a controller broker, coordinator, consumer, rebalancing, offsets, offset management, zookeeper. Kafka depends on zookeeper. We'll see that as well. What is the role of a zookeeper? We'll understand the zookeeper as well, so which will help us. I will give a general, not only with respect. We'll learn first with respect to Kafka how zookeeper is being used. That itself will give you an idea of how zookeeper fits in a distributed applications. Then we'll see delivery semantics. So delivery semantics could be at least once, at most once, and exactly once. So these are all our delivery semantics. So let's understand the concepts one by one, or the components of Kafka one by one. Now, as I said, Kafka is a distributed message queue, meaning there will be again involved multiple systems. Any number of systems could be there. Sorry. So we can have a. This is how your Kafka cluster look like. This will be system one. This will be system one, system two, system three, system four, system five. Again, it will be having some CPU core, CPU core, RAM, and hard disk. Now there are components inside. Some daemons will be running inside your Kafka. So those daemons means a long running processes. So those daemons are called as brokers. Broker one, broker two, broker three, broker four, and broker five. These are all our brokers here. They are the main working horses of your Kafka clusters. Without brokers, you don't have a anything can be done with your brokers. Nothing can be done with the Kafka cluster. Brokers are very important. Now, who will send the data? We know that I said that your applications can come in here. Your click application, your clicks, or your sensor data, or your ad ad impressions. All these applications can be sending the data to the Kafka cluster. So they will not directly send it. There has to be some Kafka component embedded in these things. So that Kafka component is nothing but a producer. So producer is the Kafka library. So the producer always sits at the client side. Producer always sits at the client side. So there is a producer for clicks application. So you may write a producer for sensor application. You may write a producer for ad impression applications. So producer is what a developers will write the code. Developers, that's where the coding comes into picture with respect to Kafka. So you have to develop a producer code. You have to write the producer code, integrate with the client application, and get the data from the client application and send it to Kafka. Any events that happen on the clicks will be sent as messages. So you need to always keep in mind that producer is the one which will be sending the messages, and producer will be always sitting on the client side. And the messages that are sent that are sent to the brokers. These messages are sent to the brokers. As the name itself says, broker is the middle person we can think of which transfers the data from producer to consumer. Now consumer sits on the analytics applications or some other application. So here, so these are all our consumers. So you can have a web consumer also, web application. From Kafka directly, a web application can consume the data directly from the Kafka here. So like Vertex. So these are all the framework. Vertex WebSockets. Vertex is developed using the WebSocket. So those things can directly consume the data from Kafka and display it on web UI. It need not be stored in some Cassandra, and then the web application need not get it from Cassandra or some MySQL. It can directly get the data from Kafka and display it on the web UI. So your consumer actually will be, if you are using Spark streaming, Kafka consumer will be embedded here. Here it is Kafka producer. All these are Kafka producer. So if you are using a Spark streaming, your consumer will be consuming from here. So it will connect to this broker and it will start consuming the data. Any consumer you are using. If you are using a Flink streaming application, so you will have a Kafka consumer here embedded inside. So it may get the data for sensor data. Similarly, you can have a web application. So again, your consumer will be here. It will be again getting the data from some broker. So as we can see here, your data is your clicks data can be sent to multiple systems. You are not restricted by a single system. Your messages are distributed across the system. And as you can see here, the broker daemon is acting as a middle person, which receives the data that producer sends, and then it sends that messages to the consumers. So it acts as a so broker is the central point of communication. Every time the data transfer happens through the broker itself. There is no other way to transfer the data, it's only the broker. If a broker goes down, the communication stops. There will be no communication from the producer to the consumer. The data will not be transferred from the producer to the consumer. So that's the generic idea of how a broker looks like. Now as we can see here, different messages are being sent. Clicks messages are being sent to the Kafka cluster. Sensor data is being sent to the Kafka cluster. Add impression messages are being sent to the Kafka cluster. Now, when all these messages are sent to the Kafka cluster, how these messages are differentiated? Are these messages mixed and kept in Kafka, or they are separately kept in the Kafka cluster? So how these messages are separated or differentiated, or how they are segregated? So in fact, clicks data is kept separately, sensor data is kept separately, add impressions data are saved separately in the Kafka cluster. So to understand that, let's see how the things work. I will just give we'll see that one thing. So as all the frameworks are downloaded and installed in the opt folder. So I also have Confluent. So Confluent Kafka, if you download only Apache, sorry, if you download only Apache Kafka, you will get only Kafka message queue. You will only get Kafka message queue. You have to explicitly download Kafka Connect, Kafka REST proxy, Kafka streams. All those things you have to separately integrate. But if you use Kafka Confluent, you will get all the frameworks. Okay, there is one more component I forgot to say. I forgot. So there is one more component here inside Kafka. So that is a schema registry. Schema registry is again there. So schema registry, uh, we need not know about the schema registry as of now. A schema registry comes somewhere here. I mean, let's forget it. As of now, it is not required. So schema registry comes here. So this also can use the schema registries. Spark streaming can also use the schema registry. So they both should be the producer, the ones which sends the data to Kafka. They should use the schema registry. The one which consumes the data from Kafka, they will also using the schema registry. But we'll see what is schema registry later. Now, as I said, when we download Confluent Kafka, we get all these components. Everything will get with Confluent Kafka. Otherwise, we have to explicitly download most of the stuffs. Now keeping these things in mind, let's understand Confluent. We'll understand how the data is separated. How the data is separated. To understand that, we'll start the Kafka server. We'll start the Kafka server. And I also said that Kafka depends on Zookeeper. Kafka depends on Zookeeper. So how it depends, we'll see that later. So we will first start the Zookeeper first. So Zookeeper server start. This is how you start the Zookeeper server. And to this you need to specify some properties file. So that properties file is in the etc folder of Confluent folder. etc Kafka, then zookeeper.properties. So it will this properties will have on which IP address and which port this Zookeeper server will be running. So some details about the Zookeeper will be there. So Zookeeper is running on 2181 port. So let's open one more terminal. On one more terminal, again you will start now Kafka server. etc Kafka. So again it also takes server.properties. Again server.properties has properties related to the Kafka server. Like which on IP address it will be running, which port it will be running. Uh, it has to connect to the Zookeeper server. So Zookeeper details will also be there. How long the data should be stored on the disk. So many things will be there in the properties file. So when we start a Kafka server, actually we are starting a broker. So to give a better understanding, let me put it in this fashion. So we have started a Zookeeper. Zookeeper is again a distributed framework. It will be running on some separate system. Zookeeper will not be running on the same system where the Kafka brokers are running. So since I'm having only one laptop, I'm running everything in a single system. Otherwise, Zookeeper will always be running on some other systems. And brokers will have a separate cluster. Now when I say Zookeeper server start, we'll be starting the Zookeeper. And when I say Kafka broker start, Kafka broker start, sorry, Kafka server start, actually a broker will be run. So what I'm trying to say here is you have to log into all the system and say Kafka server start. You have to SSH to each system. Usually the admin person will do. The admin person will SSH to each system, and in each system they have to give this command. Kafka server start, etc Kafka server dot properties. So every system will have a different server dot properties. Its IP address will be different. Some other configuration may also be different. So in which case a broker will be started in every system. So we'll start the broker here. Now once we start the broker, Kafka brokers always by default port is 9092. The port number is 9092. Somewhere it should be mentioned. Okay, we can see that later in the configuration file. We will be having that in the properties file. So our broker is up and running. So let's assume that multiple brokers are up and running. Now how do I our main intention is how the data is separated, how the messages from one application is separated from the messages of another application. So that's where topic comes into picture. So topic is all about separating messages from one application with from other another application. It is just like grouping similar data together, grouping similar messages together. So the admin person will then once all the brokers are started, once all the brokers are started, we'll take one more terminal now. The admin will start, sorry, will create a topic. Let's say I want the topic. So this is the command the admin person will give. Kafka topics hyphen hyphen zoo, where the zookeeper is running, and the option is create a topic. Option is to create a topic, and we can say Apache. The topic name is you can give anything. So let's say I will give the topic name as add logs. Add logs. So along with that topic name, so we will also say how many replications we want and how many partitions we want. Replication is for high availability. Partitions is for scalability. You want to scale because you don't want all the messages to be in one system. You want it to be distributed across the system. Hence those many partitions will be created. Because of partitions, you have a distributed message queue. So here we are saying partitions as 3. So your data will be actually stored, as I said, Kafka is a persistent message queue. Kafka is a persistent message queue. Your messages will be stored on the disk. So when we say it will be stored on the disk, which path it will be stored on the disk. So those information will be there in the properties file. So if I go to etc Kafka server.properties, which contains the broker's properties, so it will have broker ID. So broker ID should be a unique ID. For each broker, it should be a different unique number. So if you are having 5 brokers, you can give 5 different unique numbers to these brokers in different files. Every system will have a server dot properties. So those server dot properties will have different number for broker ID. Similarly, by default it will be running on the 9090 port. Since it's a single system, you don't have to specify the host name or the IP address. Otherwise, you need to specify your IP address here. Usually the public IP address will be specified here. And all your messages will be stored to the path pointed by log.dirs. So your messages will be stored in this path by default. Usually you should not make it as temp. So usually in the in the root directory you can create some data folder and Kafka folder directory, and you can point your log directories to that path. But by default it will show as temp Kafka logs. So all your messages will be stored here. Now let's see how this path looks like. Let's go and check how this path looks like. So if I do an LL in this directory, you can see here three folders, three directories has been created. Addlogs 0, addlogs 1, addlogs 2. Because we created three partitions. Now since it's a single system, all the three directories are created in this system only. But in reality, it could be on any of the five systems. Addlogs 0 will be here. It could be anywhere. Addlogs 1, sorry, addlogs 0, addlogs 1, addlogs 2. So anywhere these directories can be created inside inside the log directories. I mean to say inside. Anyway, we have already seen that, right? etc kafka server dot properties. So whatever path is given here, inside this path, folders will be or directories will be created for each topic. If the topic name is addlogs, directories will be created by the name addlogs, and based on how many partitions we specify, those many suffixes will be added: 0, 1, 2, and 3. So three partitions will be created, but in real time it will be in this fashion. Now again if I say topic equal to sensor, and I say partition equal to 3, and I say again replication 1. So again three directories will be created. So sensor hyphen 1 may come here, sensor hyphen 2 may come here, sensor hyphen 0 may come here. I did not give the 0, right? Sensor 0 here, sensor 1 here, sensor 2 here. So that's how the data will be distributed. So when the producer, you have your ad server, you have your ad server producer, you have your sensor application. Inside the sensor application you will have your uh, uh, the producer code you have written. So this producer, ad server producer, will send the data to this, it will send the data here, and it will send the data to this. this broker. The sensor producer, the sensor producer will send the data to broker 1. The sensor producer will send the data to broker 3, and the sensor producer will send the data to broker 4. Now broker 4 will save that messages to this directory. Broker 3 will save the corresponding messages. Sensor messages will save it to the sensor directory. Add log messages it will save to add log directory. Similarly, broker 4 and broker 5. So that's how the data is sent from the producer to the broker, and that's how the broker will save these messages to the file system. So if I go inside that, so we have here add log 0, add logs 1, add logs 2. Let's go inside this directory. If you go inside this directory, we can see that the messages will be appended to this file. Any new messages comes, that messages will be appended to this file. So that's the reason I was saying Kafka is a persistent message queue, because any message that comes, that messages will be appended to this file, and that is the responsibility of the broker. The broker will append those messages correspondingly. So as you can see, is a distributed, because of partitions, your messages are distributed across the cluster, and since it is saved on the disk, it is a persistent message queue. So that's what we wanted to discuss here. So we know what is a topic, we know what is a partition. There are more things to know about these things. I have just given the overview. I have only given the overview of this producer, broker. There are a lot of other stuff we need to learn about these things. But I hope till here things were clear. Till here things were clear. Okay. So let's wind up the session here, and let's continue tomorrow, same time. Thanks everybody. Have a nice day, and others good night.